Hello everyone, this is my video series called Six Sigma in Action. In this video series, we will explore real life examples of Six Sigma case studies using Minitab. If you are a student or a quality enthusiast or a professional looking to improve processes and drive better results, this video series is for you. We will be using the DMAIC approach here: define, measure, analyze, improve, and control each of these steps. For every problem that we cover, we will walk through each of these steps within the DMAIC framework, use the Six Sigma tools in Minitab, and show how structured problem solving can drive real world results. Now let's get to chapter 1. Dude, why is my burger so greasy? The first phase in problem solving is define phase. Define phase is which you describe the problem better, understand what are the impacts of the problem, and what would success look like. Imagine you are an operational manager at a health conscious fast food restaurant. Customers have started complaining that your burgers have too much grease, too much fat in them, much higher than what you claim. And your claim has always been that my burgers have, on an average, 15 grams of fat. So there is a problem here. The problem being discrepancy between customers' perception and your claim. This needs to be understood better. So our next phase in the DMAIC approach is going to be the measure phase, where you collect the reliable data in order to understand the current state of the problem. For the measure phase, what we need to do for this current problem is select the 20 burgers randomly from the restaurant and measure their fat content. Let's say we did the measurement and here's the results we got. I've already populated in the Minitab C1 column the fat content for the 20 burgers that were measured randomly. Now, the next step in measure phase is to check for process stability. Now, the reason you need to look for process stability before you go ahead in the process and look for normality and other such things is because you want to know if this variation is a common cause variation or there is some sort of special cause variation in there. Of course, if there is some sort of special cause variation and the process is not stable or under control, then looking for normality is kind of meaningless. That is why you want to first check for stability before you do anything. And the way to do a stability check here is going to be using control charts. And since we have individual values, we will be using IMR. In case we had subgroups, we could have used X bar R or X bar S, depending on the number of subgroups. But here, since we have individual values, we'll be using IMR chart. Select the C1 column and then hit OK. And there you have it, your control chart. And it shows that the process is very much stable and under control. So we are good to proceed further. So our next step in this measure phase is going to be to check if the data we've collected is normal or falls under normal distribution. And then also check if the confidence interval for the population mean fat content at least has 15 grams in it or not. If 15 grams is not even within the confidence interval for the population mean, then we know that we are way off in terms of what we claim and what we actually produce. The way to do both of these on Minitab would be through graphical summary. And how do you get to graphical summary? Just go to stats, basic statistics. There you'll see the option of graphical summary. Select the column. Confidence level can be 95 and hit OK. So there you see the report. As you can see here, the p-value is 0.624, which is greater than 0.05. So you can say that the distribution is normal. And over here, we can also see that the confidence interval for the mean is 15.625 to 17.595. meaning that 15 grams, which is what we claim, doesn't even fall in the 95% confidence interval of the population mean fat content. So that means that what we claim is way off from what we are actually producing over here. So that means that this issue of the burgers being too greasy and having a higher fat content than what we claim is very much real. So in the graphical summary itself, we had seen here that 95% confidence interval for standard deviation lies from 1.6 to 3. But the operating manager was under the assumption that the standard deviation is going to be less than 1 grams. That's one of the assumptions they had when they were producing their burgers. To do a specific test for that, we will have to do something called as one variance. And that is going to be our next step in the measure phase. Verify standard deviation claim. Perform one variance test in Minitab to test if the standard deviation of fat content is less than 1 grams as it was assumed by the operating manager. To do the one variance test, all you have to do is go to stats, go to basic statistics, go to one variance. Here you can leave this as each in a column. Select your column, go to options, and as your alternative hypothesis, you can choose standard deviation less than hypothesized standard deviation. If you do greater than, if you do less than, then that gives you the upper bound on the 95% confidence interval. And if you choose standard deviation greater than hypothesized standard deviation, that'll get you the lower bound. Since we are more interested in the upper bound, we can leave it at standard deviation less than the hypothesized standard deviation. Hit OK. You don't have to do the hypothesis testing. Just hit OK, and that gives you the standard deviation and also the upper bound on the standard deviation as per the 95% confidence interval. This score is as per the bonnet test, and this score here is as per the chi square test. Either way, it tells you that your standard deviation is not less than 1. In fact, the standard deviation upper bound can be as high as 2.8. So that kind of tells you that there is strong evidence that the standard deviation is not less than 1. Before we move to the next stage of the demake process, the operating manager also wanted to do a survey to find out the number of dissatisfied customers. So he does a survey and finds out that out of 1,000 customers, 83 customers were found to be dissatisfied with the burger. Now, from this survey data, he wants to calculate the confidence interval for the true population of unhappy customers. From a sample data, find the value for the true population. And to do that, we have a test called one proportion test in Minitab. In order to do one proportion test, you go to stats, you go to basic statistics, go to one proportion. Here you can choose summarize data. We know the number of events is 83. So we will write 83 here. And 1000 is the number of trials. And in options, you can choose again proportion less than hypothesized proportion will get you the upper bound, which is what we are interested in. The 95% confidence interval upper bound for dissatisfied customers. If you choose again proportion greater than hypothesized proportion, that'll get you the lower bound. But you want to do the upper bound. So this method is fine, and then you hit OK. Hit OK again, and that gives you the 95% upper bound for P, which is 0.098. And that tells you that 9.8% of the true population at max is the dissatisfied customers. Obviously we want to reduce this number, and that is what we will work in the next phases of the demake process. So the next phase after the measure phase is the analyze phase. Analyze phase is where we try to find the root cause of the problem using the data we measured. In our case, the operating manager did the root cause investigation, and what he found was that the fat content variation is mainly because employees are adding different amount of oil on the grill. On every different grill, there are different people working, putting different usage of oil, and that is causing high variation in the fat content. We were not going to spend too much time on the analyze phase because that is done outside Minitab. But essentially, root cause investigation is what happens in analyze phase. Moving on to the next phase, we get to the improve phase. Improve phase is where we try to fix the root cause that we identified in the analyze phase. In our case, the solution that was implemented was installing an automatic oil dispenser on all grills and standardizing the oil quantity for every burger. And after the solution is implemented, all we have to do is redo all the measurements that we did in the measure phase, starting from collecting the fat content for 20 burgers and so on and so forth. So here I've collected the data for 20 burgers, or the fat content for 20 burgers after the improvement was done. Here are those values. Now we're going to do the same process that we did in measure phase. Start with checking the stability of the data. For that, we have to go to stats, control chart, variable chart for individuals, IMR, and obviously select the improve phase measurements and hit OK. And so basically, this shows us the IMR control chart, and looks like the data is under statistical control and stable. So we can proceed to do the other analysis. Next what we need to do is to check for normality of the data and also the confidence interval of the mean. To do that, we're going to be going to basic statistics and graphical summary. So here, let's select column C2 because that's what we are interested in. Confidence level can be 95, and then hit OK. So since this is the report for the fat content we've collected in improve phase, p value is 0.9, which tells you that this is a normally distributed data. So we're good there. It's also giving you the 95% confidence interval of the mean for the population, and looks like 15 grams is within that confidence interval. It ranges from 14.88 to 15.22. So yeah, 15 grams looks like it is within that confidence interval. So that's a good sign. It's also giving us the 95% confidence interval of the standard deviation. And if you remember, one of the assumptions that the operating manager had, or one of the hopes that the operating manager had, was that the standard deviation is less than 1 grams. After the improvement, it looks like standard deviation is definitely less than 1 grams. It ranges from zero point 0.2 to zero point 0.5. But we obviously going to run one variance test to specifically test that if standard deviation is less than 1 grams. To do that, again, go to stats, basic statistics, one variance, and you can select the improve phase, fat content, and this one can remain same. Go to options. Since we are looking for the upper bound on the 95% confidence interval for the standard deviation, we can keep standard deviation less than hypothesized standard deviation, hit OK, and let's see what we get. So, according to one variance test, the 95% upper bound for standard deviation using the bonnet test is zero point 0.5, using the chi square test is 0.49, and the standard deviation is somewhere at 0.35. So, those are all well within 1 gram. So, looks like the improvement is working and we are getting standard deviations less than 1 gram. So we did our test on one sample of 20 burgers in the improved phase. But obviously, to be more sure, we can collect more samples of data and then see if the confidence interval of the population has 15 in it. Either we can collect more samples or we can simulate more samples. So, how do you simulate more samples? You have to go to cal, go to random data. We know that our data is normally distributed, so select normal. Over here, since we want 20 values in each sample, we can put 20 and store in the column. We can store the values in the column C3 to C12. And since the mean, we know that the mean for this sample here was 15, so we can put that as 15. And the standard deviation for this sample was also around zero point 0.5, so we can put zero point 0.5 here and hit OK. And that's going to produce 10 more samples from C3 to C12. They're all normally distributed and have a mean around 15 and standard deviation around zero point 0.5. And now we can look for the confidence interval of the population and see if 15 lies within that confidence interval. But before we do that, let's try to see if all this data is under statistical control or not. And that can be done in a group as well. To do that, you have to use this time the X bar S chart, which means you go to stats, you go to control charts, you go to subgroups X bar S. Since the number of sample is around 10, you select observation for a subgroup are in one row of the column. You select your column. So it's gonna be from C3 to C12. Select and then you hit OK. And there you have a control chart for all the samples together. And looks like the control chart is under statistical control and stable. So we can move further. Now, in order to check for the confidence interval of all the samples together, for that we can use the interval plot. For interval plot, you can go to graph, go to interval plots, and since there is multiple columns but no groups, you can select multiple y's, simple, hit OK. Here select your columns C3 to C12 and then hit OK. And there you can see the confidence interval of the population for all of these samples from C3 to C12. And one more thing you can do is edit this graph and add a reference line. So let's say we want a reference line at 15 to show specifically that all of these confidence intervals includes 15 in it. So that means that 15 grams of fat is within the confidence interval for multiple samples, so we can be very much sure that our process is producing 15 grams of fat and not too much or too less. So the next thing, if you remember in the previous measure phase, the operating manager had done a survey, and in the survey he had found that 83 out of 1000 customers were dissatisfied, and so about 9.8% of customers were dissatisfied. This time, after the improvement was done, he did another survey and found out that 25 out of 1200 customers were dissatisfied this time. So we're going to try to find the upper bound for the population based on that sample survey. To do that, go to stats, basic statistics, one proportion, and summarize data. The number of events is 25. 25 is the number of dissatisfied customers. Number of trial will be 1200. And go to options. Since we were looking for the upper bound on dissatisfied customers, we keep proportion less than the hypothesized proportion. Confidence level is 95. This method is fine, and hit OK. And that shows that the upper bound is about 0.028. So 2.8% is the maximum of dissatisfied customers after the improvement, which the operating manager can live with. And it is a big difference compared to 9.8%, which was during the measure phase. So that overall concludes the improved phase of the DMAIC process for this case study. So after the improve phase, our next phase in the DMAIC framework is control phase. Control phase is all about sustaining the improvements or the gains we made and then preventing the backsliding. In our current case study, things that can be done to sustain the process is maintaining the automatic oil dispensing system, standardizing the process, creating checklist, audits, control charts, training the employees to follow the new method, and performing periodic quality checks. The goal here is to make sure that the burgers always meet that fat content standard of 15 grams that is claimed by the restaurant. And we lock in the improvements we made in the improve phase. So, overall, that concludes this case study. Thank you so much for watching, and I'll see you in the next one.